about this guy. Does anyone know who this guy is or was? He's a guy called Wernher von Braun. Who or what is Wernher von Braun? Wernher von Braun was the world's greatest rocket scientist ever. He came up with an incredible rocket called the V2. In 1944, in the Second World War, these things were being launched from France and from Holland, and they were going over to London and killing some of my relatives. The transit time, the flight time of one of these rockets was only 150 seconds. It was at least 15 years ahead of any technology anywhere in the world. Now, I need to tell you, well, first of all, this guy unfortunately was working for Adolf Hitler, so he was on the wrong side. But let me just tell you about the rocket engines. And if I may, I'll just build you a rocket engine. Okay, I can build rocket engines, I'm quite good at them. Now, what you need is some liquid fuel. Now, in this case, he used liquid alcohol. It was a dreadful waste. Okay, and then he had liquid oxygen. And then you had a couple of valves. Valves are quite important because you can open valves, but you can also close them if things go wrong. That's important for the rest of the story. You then have a pump, and you pump the alcohol plus the liquid oxygen into the burner, set fire to it, and off it goes. Sounds very basic. It's very difficult to make it on this scale. And Wernher was the first guy to build rockets of this size in the world. There was no defense against these rockets, on our side anyway. And so as a result, the only way they could stop them hitting London was to invade Europe, France obviously, D-Day, and actually drive them back towards Germany. The American Marine Corps were told to get Wernher von Braun on the way. Wernher von Braun, very arrogant man, he actually hired a train and went to meet the Americans. And he got off the train and said, "I am Wernher von Braun." They said, "God damn, Wernher von Braun, we have a message for you from the American president. Wernher von Braun, you are an SS ranking major. You have run slave labor camps building your rockets. Thousands have died whilst you were in charge. We will now take you to a court, find you guilty of war crimes, and hang you by the neck until you're dead." That's option number one, Wernher. Option number two, welcome to America, Wernher. Now, Wernher unsurprisingly went for option number two. And he set up, basically, the American rocketry, later to be known as NASA. He also took his German team with him, 118 Nazi rocket engineers. Now, this is embarrassing to the American government. They want their brains, but the background is politically incorrect. So they had to hide them somewhere. Guess where they found to hide 118 raving Nazi rocket engineers? Alabama. It's a good start. Okay, I mustn't say that. Wernher von Braun and his German team, and make no mistake about it, actually designed and built the rockets that took men to the moon. It was a German project. Now, what sort of atmosphere do you think grew up in the Marshall Space Flight Center? Well, it was run by one man, Wernher von Braun, and he was a genius. And unfortunately, like a lot of geniuses, genii, he always said, if anyone argues with me, because I'm a genius, they must be wrong, because I'm a genius. And if anyone argues with me, they must be stupid. And I don't want stupid people in my team, so anyone that argues with me must be removed. It's what we call basically a dictatorial style of management. And we talked about it briefly this morning, very dangerous. Now, Wernher von Braun got older and he had to hand over the reins of power to another guy. And the guy he chose was a guy called Bill Lucas. He was American, born and bred, but brought up the Wernher von Braun way. I am a genius, no one argues with me. So, von Braun retired, later died, Bill Lucas took over. I'm now going to read an anonymous memo that was sent to the inquiry on the Challenger accident about 2 weeks after the accident. It was signed Apocalypse. It was anonymous. It turned out to be one of the senior managers at Marshall. Flight Center, Space Flight Center, is run by one man. 1, 2, 3. Oh, we're back online. Fantastic. Well done, chaps. Okay, Space Flight Center is run by one man, Bill Lucas. As center director, he's established a personal empire where the only criteria of advancement is total loyalty to this man. Loyalty to country, NASA, the space program means nothing. Many high-skilled managers, scientists, or engineers have been buried in the organization because they underestimated the man's reaction to any dissent. So not a nice man, but a very successful man. And a lot of psychopaths are successful. Marshall became effectively isolated from the rest of NASA. Now, I know you're going to find this very difficult to comprehend, but in a lot of organizations, departments don't speak to other departments. Can you even begin to imagine that concept? So in NASA, Marshall were isolated. Marshall came up with a liquid-fueled engine to power the space truck, now called the Space Shuttle. It went in front of Congress, and they said too expensive. Even the accountants couldn't help them with this one. They said that's basically the cost of the technology. This is when a congressman said, "Excuse me, NASA, yeah, that's liquid-fueled engines. There is an alternative rocket engine in the world." And NASA said, "We know about that, and we don't want to use it." And it's called solid-fuel booster rockets. Now, what I'm going to do, may I just steal this? I'm now going to build you a solid-fuel booster rocket. You get a very thin metal tube. You put into the tube a high explosive called P-BAN. It's 500% more powerful than TNT. You then put your monkey or your satellite on top of this pile of high explosive and put it on the launch pad. Would you like to just hold that? Okay, that's marvelous. You then, hold it carefully, it's very, very delicate. You then light the fuse and then you hide. And you go about 3 kilometers away. 4, 3, 2, 1. God bless America. And hopefully it goes. It's like a huge stick of dynamite. And if it doesn't go, I'll show you, thank you, what can happen. Without boring you, when you ignite it, you get a huge pressure bulge in the tube. If there's any weakness in that tube, it'll blow open, and if the whole lot goes off in one go, it's just like a huge bomb. And then, of course, as one NASA guy said to me, you then end up with a totally disassembled satellite or a truly pissed-off monkey. Okay, so these things used to blow up 1 in 20 on the launch pad. No human being should go on one of those. But the nice thing about them was they were cheap. So, for the first time ever, it became apparent that cost would need the same considerations, the user design parameters of weight, safety, and performance. NASA had never had to worry about a budget in their lives. Suddenly, it was all about the money. And that's how they came up with this crazy craft called the Space Shuttle. Very quickly, the Space Shuttle. It's too big, too heavy, wrong-shaped wings. I could go on for hours. It's got liquid fuel engines, 3 of them, underneath it. So no American will ever go up in a vehicle that is not powered by liquid fuel engines, because the nice thing about liquid fueled engines, if anything goes wrong, you can close the valves. Do you remember the valves? Now, there's no room for any fuel, so there's the fuel tank. Now, the fuel tank contains between 5 and 6 million liters of liquid oxygen and liquid hydrogen. Not nice stuff. And that feeds the engines. But it's too big and too heavy to take off. So then they put on the world's largest solid fuel booster rockets. They are 14 stories high, containing tens of thousands of kilograms of a high explosive, 500% more powerful than TNT. You put these huge bombs onto the tank containing the 6 million liters of liquid oxygen and liquid hydrogen, and then you look for 7 volunteers. Whoa! Okay, that can happen sometimes. Okay, now, lovely, thank you to Russia. Okay, now, assuming you've got some volunteers, the way it works is you actually bolt it onto the ground, stop it falling over, and what they do is 10, 9, 8, 7, 6, now at 5, they open up the taps on the oxygen and the hydrogen, pour it into the engine, set fire to it. Lots of smoke, but the spaceship's going nowhere. It hasn't got enough power. 4, 3, 2, 1. By now it's rocking from side to side by a meter, but it can't take off. If those 3 engines, the liquid fueled engines, are looking good at that point, they then ignite the solid fuel booster rockets, blow the explosive bolts, and off it goes, we hope. Okay, they then tip it on its side into what they call the roll program. This is so the astronauts can see where they're going to crash. Now, at this point, it's quite interesting. You'll hear on the video in a second, they actually say to the pilot, throttle back. You think, throttle back, throttle up. This thing's got to go up to 17,500 miles an hour. Go, go, go. No, slow it down. Why? Well, they throttle the main engines, these ones, back from 104% down to 90% to 80% to 65%. Why? Wind and rain. What they discovered is actually flying through the atmosphere, jet streams and wind can make the whole thing unstable if it's going too fast. The feedback and control systems can't deal with it. The software couldn't deal with it. So what they had to do was get above the weather. It's normally 70 seconds into the flight. At that point, they say to the pilot, go for throttle up. He says, go for throttle up. And he puts the throttles through the main gates. These things got to 104%. It's amazing. You get incredible G-force on the craft. And these tubes bend because of it. Now, do you remember what I told you about the tubes? If there's any weakness in the tube, what's going to happen? It's going to explode. If they get through what they call throttle up, 70 seconds into launch, depending on the weather, they then, after 120 seconds, run out of fuel on these. We come back to them later. You then go into a low Earth orbit using the oxygen hydrogen, and then you end up with a shuttle. Oh, by the way, they then drop the tank, and hopefully it burns up in the atmosphere, otherwise it lands on India. Okay, so that's how the shuttle works. Now, let's move on with the story. Meanwhile, what does this represent to aerospace companies? Huge contracts. Now, NASA were very scared about the solid fuel booster rockets, the white rocket boosters. They wanted them built by a company that actually had a factory next to the Mississippi River. And you think, what's this got to do with space? Well, it's funny, geography has everything to do with space, not just up and down, but around the globe. If they could have a factory next to a river, they could manufacture these in single-piece precision units, pre-filled full of high explosive. They could then float them down the Mississippi River round to the Cape, and that will be good, because you want minimum stress to this tube. Unfortunately, at this point, the Mormons got involved. Have you heard of the Mormons? Very powerful religious group in the States with an excellent choir. And a very good genealogical database if you ever want to check it out. Now, the Mormons decided that the state of Utah, which is where they're from, did not have sufficient jobs out of this government contract. And they were quite right, actually. So they lobbied, that's democracy, and eventually it was decided that Utah would get to build these things. A very good company called Morton Thiokol in Utah got the contract. Now, Morton Thiokol were now going to be subcontractors to Marshall. How well do you think these Mormons from Utah got on with the boys from Huntsville, Alabama? Now, straight away, you can see there's going to be a cultural gap. And as a practicing project manager, that will be the first thing I would address. Forget the coding, forget all the clever stuff. Let's get the people together, and we'll realize that we think differently about the world, we communicate in different ways, and we have to find ways of communicating. Otherwise, this will be a disaster. Unfortunately, the people in NASA just issued great big piles of governance and procedure and said, follow these. So straight away, communication between these two vital parts of the project were failing. Your next problem is geography. There's Morton Thiokol, there's the Cape. How are you going to get a 14-story high rocket from Utah to the Cape? Now, it's too big to go on roads, and it's too long to go on rail cars, because even railways have slight corners, and it will bend the tube. Do you remember, if you bend the tube, any weakness, when you light it, it blows up. The only way they could come up with fixing it was to actually make it in sections, and then they would put the sections together at the Cape. These are the sections. They are delivered, filled full of high explosive. This is the pathetic attempt by NASA to create clean room environments at the Cape to put them together. As you can see, it's just scaffolding and plastic sheet. The next problem is, how do you stick them together? Now, welding is not recommended because they are full of high explosive. So what they came up with was a joint. Now, any engineer will tell you if you have a joint, you have a gasket, an O-ring, a seal. And just like in your cars, that's probably one of the most unreliable parts of the whole engine because, of course, it flexes. They started testing these solid fuel booster rockets, and things did not go well. The chief designer, Roger Beaujolais, who you saw in the video, he actually realized that this O-ring system was unpredictable. Every time they tested them, they behaved in different ways, and he couldn't explain why. Now, if you had a bug in your system that kind of sometimes occurred and sometimes didn't, I hope that someone in testing would say this is unacceptable, especially if the programmer said we haven't got a clue why it's happening, because it's dangerous. And that's what happened. The engineer said, I designed it, I don't understand how it works. And management said, well, what do you need? He said, I need another 2 years and another $500 million. And they said, we haven't got that, and we've got a tight contract. Fix it. He said, I can't fix it. They said, if you don't fix it, you lose your job. He said, I'll fix it. So they came up with the most amazing compromise. Listen to this. These O-rings, they're not working properly. They work, but we don't understand how they work, and there's blow-by and erosion and burning, and that shouldn't happen. It works, but we don't know why it's working. Okay, how about this? When the O-ring fails, why don't we have a second O-ring of the same design to back up the one that might fail? Does this sound good to you? It's as if you're buying a car because you've got a young family and you want them to be safe. So you buy a very safe car, and just as you're about to drive it out of the showroom, the salesman said, it's a very safe car. However, it's an interesting fault. We've heard about it. It happens randomly. It's quite exciting, really. Sometimes when you're driving along in this car, the steering wheel will come away in your hands. We don't know why. The engineers are scratching their heads. It's fascinating. So don't worry, because what you then do is you turn round to your children and you say, give Daddy the spare steering wheel. They will hand you the spare steering wheel. You'll push it on, and everything should be okay. You'd think that guy was mad. That's what NASA went for. As a result, the double O-ring became what's known as criticality 1R. And listen to this for technical gibberish. If the O-ring fails, you will have last mission vehicle included metal erosion, burn through, multiple case burst was down, and found deflagration. Have a nice day, you all. What does that mean in plain English? It means it blows up and everybody burns to death. Please use direct language when you're speaking to customers and clients. It might frighten them, but it's better to be frightened early than terrified later. In 1981, for the first time, they launched this vehicle. Crippen and Young got on board, very brave astronauts, and it worked. We now know that they were just incredibly lucky. It's amazing how lucky you can be. They launched a second one. That worked too. So now we've got skill, judgment, and experience. No, you haven't. You've been playing Russian roulette twice. Okay. Let me just show you how foolish this vehicle is. You get the bits from Morton Thiokol, you stack them up, you put on the main tank, you put on the orbiter, you wheel it out, it goes into space. This idea that it's reusable, I'm afraid, is a little incorrect. By the time it lands, lots of pieces have fallen off it, and it costs a lot of money to repair it. The interesting thing I'd like to talk about are these SRBs. To make it look environmental, which it is not, someone came up with a crazy idea that when these things come off the craft, why don't we have little parachutes that open, and they'll fall back into the North Atlantic, and we can then retrieve them using Navy divers, wash them out with Perrier water, and use them again. Do you think it's a good idea to use something like this again? It's insane. But they did it. The chief designer, Roger Beaujolais, was terrified. When he got these back, he discovered that every single O-ring had behaved differently, and he designed it and he couldn't explain it. What was worse was the same O-ring on different flights behaved differently. What should you now do? Stop. But they didn't, because by then they had 10 successful flights, and everyone was saying this is a reliable system. He tried to figure out why these O-rings had erosion and blow-by. And the only correlation he found, and he did it as a joke, was he actually plotted it against the weather in Florida when the spaceship took off. It should have had no correlation at all. So it turned out that the colder the weather in Florida, the more erosion and blow-by you got, which meant there could be a temperature so low that the whole thing would blow up. He went to see his boss. His boss said, go and see Mr. Lucas. Do you remember Mr. Lucas? So he went to see Mr. Lucas, and it wasn't pretty. When people go in front of Dr. Lucas, they know if they use words like think, or feel, or judgment to try and explain something, they will be shot down in flames. Mr. Lucas wanted data, absolute numbers, no error for judgment. It had to be absolutely correct. And of course, this was just a theory. And so Lucas said, you haven't proven that this thing will blow up, so we continue. And so believe it or not, the flights continued. Just did that to wake you up. Is that okay? Right. So the 15th flight was actually a winter launch, 1 year before the Challenger Christa McAuliffe flight. It went up, it was very cold, and they know it was only 1 second away from failure. But they survived. But after winter, February, March, April, it gets warmer. So the problem went away. Well, it wasn't going away, it was waiting for the next winter. All the way through that year, the engineers were saying, this has got to stop. This is Russian roulette gone mad. The Christa McAuliffe flight was unfortunate. It was Christa McAuliffe on board. It was very, very political, had maximum coverage, and unfortunately they had software errors. Can you imagine that? Software errors. Now, as a result,